Today's lecture is covering how to combine different types of sources. We're going to start with combining voltage sources that are electrically connected in series. And we're going to do this by working an example using a single loop circuit. So on the board we have a single loop circuit that contains 3 voltage sources all connected in series with a single 10 ohm resistor. Because all of the elements are in series, I can actually move them around the circuit to kind of clear things up. So what I'm going to do is I'm going to redraw this circuit, but I'm going to have all of my voltage sources on the left-hand side and my resistor on the right-hand side. To accomplish this, what I'm really going to do is just slide this 6-volt source down around this wire, and I should see that my positive polarity terminal, as I move this down and over, should be on the right-hand side, and my negative polarity terminal should be on the left-hand side. So what I should get is my 12-volt source is going to stay the same. My wire going up, my wire going down. My 3-volt source, I'm not moving it, so it's going to stay the same. My 6-volt source will be down here. And again, the negative polarity terminal should be on the left, and the positive polarity terminal should be on the right. Here's 6 volts. And I'm moving my 10 ohm resistor to the right-hand side. So here is my 10 ohm resistor. And what I'm going to do is I'm going to effectively draw a pair of terminals. These are just going to be open circuit terminals, so they in no way, shape, or form influence anything. And I am going to label an equivalent voltage VEQ. So this equivalent voltage is the voltage that's seen by this 10 ohm resistor. It doesn't really care if you have a 6-volt source in series with a 12-volt source in series with a 3-volt source. It's just going to see some amount of voltage that is a combination of those 3 voltage sources. We can write a Kirchhoff's voltage law equation for this loop that contains only the voltage sources to solve for this equivalent voltage. So if I start in the bottom left-hand corner and work my way clockwise around this loop, I will see negative 12 volts plus negative 3 volts plus VEQ plus 6 volts is equal to 0. And then I can do simple algebra to rearrange this. So I have VEQ on one side of the equal sign. VEQ is equal to, when I move the 12 and the 3 over, that's going to give me positive 15, minus this 6 gives me 9 volts. So from the perspective of the 10 ohm resistor, it sees a 9-volt source instead of 3 different voltage sources connected in series.